Hello everyone, this is Gopinath Ashokan. Recently I have done a project of potato disease classification using deep learning. In this video I explain my project. In agriculture industry, the farmers are struggle to identify the disease in potato plants, whether it's an early blight, late blight or healthy images. This lack of clarity makes it difficult to the farmers to apply the fertilizers and treatments and its impact on the crop yield and quality. To address the issue, we have developed the Streamlight application utilizing deep learning models with TensorFlow, and this application accurately classifies the image based on the disease, and also it enhances the production of quality potato plants. First, we need a data set. I download the data set from the Kaggle. I given the link in description. In our data set, totally 3 folders are there. First one is early blight. Second one is healthy. Third one is late blight. Both early and late blight are fungus disease and it affects the potato plants. In this project, I used Google Colab, so I upload all the images in Google Drive and I mount the drive in Colab. Next, I import all the required libraries. NumPy help to numerical operations. Matplotlib help to both plotting and reading the images. TensorFlow is an open source deep learning framework and it help to building and deploying the model using neural network. Pillow used to reading and manipulating images, and finally warnings used to ignoring the output warnings. Next, I reading all the images from the directory using TensorFlow. The total images are 2948, and here I mentioned the batch size is 32. That means all the images are split into batches, and every batch the maximum number of images are 32. And next I mentioned the image size is 256 into 256 pixels. That means all the images are resized into 256 into 256 pixels uniformly. Next, the folder names are class names. And length of our data set is 93. That means 2948 images are split into 93 batches. Next, I want to split the dataset into training, validation and testing. So I create a function to parse the dataset, and here I mention the training size is 80%, validation is 10% and test size is 10%. So if I run this function, the dataset is split into training, validation and testing. So 74 batches into training, 9 batches into validation and 10 batches into testing. Next, in the for loop, I take the one batch from the training dataset and I read the image label and their shape. The image size is 256 into 256 pixels. 3 means RGB, it's a color image. And the image is converted into machine readable numerical array format. Next, I build a data pipeline for data augmentation in both training, validation and testing dataset. Catchy function help us to avoid the data reading on every epochs, and shuffle can help us to shuffling the images in every epochs, and finally prefetch function can help us to prepare the next batch of images in advanced. So this data pipeline to reduce the time in model training. Next, I mentioned the channel size is 3. That means our images are color images. And the input shape is combination of batch size and image shape. So in our data set, the batch size is 32 and the image shape is 256 into 256 pixels and 3 is RGB. And I mentioned the target is 3. That means early blight, healthy or late blight. Next, I build a pre-processing layer and it can help us to resizing the image, rescaling the image between 0 to 1, randomly flip the images and randomly rotate the images. During the training process, our model can understand the image data very well. Next, I build a convolutional neural network architecture for model training. Here I mention the filters and units for trial and error purpose. Based on the training output, we change the filters and unit values to get a better output. Next, in model summary can give the clear overview about the output shape on every layer. So in the beginning, the output shape is 32 batch, 256 into 256 and 3 is the RGP. So it can clearly indicate how the input shape is modified into each and every layer to reach the final dense layer. 32 is the batch size and 3 is the output class. So finally, our model can given the probability of each 3 classes and the maximum probability is the output. The total trainable parameter are 1,83,747. Next, we use the Adam optimizer and sparse categorical crash entropy for loss calculation and accuracy for metrics. And finally, model.fit function, we passing the training dataset, mention the batch size, epochs, and passing the validation dataset. In every epoch, it calculates the training loss and training accuracy, and also using validation dataset, it calculates the validation loss and validation accuracy. The training is completed. The training accuracy is 99.9% and the validation accuracy is 99.6% and the testing accuracy is 99.06%. Wow! So our model performed very well on both training and evaluation. Next, I visualize the accuracy and loss in plots using matplotlib. Before that, I save the model. So this plot visualizes the both training and validation accuracy and loss. Next, I developed the Streamlit application and deployed in the Hugging Face platform. So you can easily upload the image and it can correctly predict whether it's a yearly blight, healthy or late blight. For example, I upload the image and it can correctly predict it's a early blight with a confidence of 100%. Now I upload the another image. It correctly predicted it's a healthy image with a confidence of 99.94%. And I upload one more image. Now it's correctly predicted it's a late blight image with a confidence of 93.74%. So in agriculture industry, the farmers can take a photo and upload the image in our application. It can correctly classify whether it's a early blight, healthy or late blight. So based on the output, the farmers can apply the correct fertilizers and treatment methods to enhance the production of healthy potato plants. If you like this video, click a thumbs up button, comment your thoughts and share the video, and don't forget to subscribe and follow Gopinath Ashokan. We'll see you in the next video.